Welcome to the DIY Honda Garage channel. The DTC P1549 indicates a specific issue within the charging system of the 2006 to 2011 Honda Civic. This diagnostic trouble code signifies that the vehicle's charging system is experiencing high voltage, potentially leading to severe electrical system malfunctions. In this context, the main component involved is the alternator, which is responsible for converting the mechanical energy from the engine into electrical energy to charge the vehicle's battery and power its electrical systems. An improperly functioning alternator can not only cause the battery to fail, but may also damage sensitive electronic components throughout the vehicle. The alternator is usually located at the front of the engine, mounted directly to the engine block and belt-driven. If high voltage is present due to a connected high-voltage battery, this can also trigger DTC P1549. DTC P1549 refers specifically to a high-voltage issue within the vehicle's charging system. The primary component affected by this error is the alternator, which plays a crucial role in generating electrical power while the engine runs. It is located at the front of the engine compartment, typically driven by a serpentine belt connected to the crankshaft. The alternator charges the vehicle's battery and supplies power to electrical systems when the engine is operating. If the alternator is faulty and producing excessive voltage, it can lead to damage to various electronic components, including the battery itself and sensitive circuitry. To identify the issue accurately, it is essential to gather freeze-frame data prior to commencing any troubleshooting procedures, as this may provide insights into the precise conditions that triggered the fault code. Several possible causes can lead to DTC P1549 being triggered. The most common cause is a faulty alternator. It may either generate too much voltage or fail to regulate voltage properly. Additionally, if a high-voltage battery is connected to the system, it may directly cause this DTC to appear, indicating an improper operating condition. Poor electrical connections, especially around the alternator and under-hood fuse relay box, can also initiate this error code. Furthermore, if terminals are loose or corroded, they may not provide a stable electrical connection, further complicating the issue. Lastly, general malfunctions within the electrical system may be responsible, potentially requiring further in-depth diagnostics to identify specific failure points. Several symptoms may accompany DTC P1549 and highlight the underlying issue within the charging system. Firstly, warning lights, specifically the battery and check engine light, may illuminate on the dashboard, alerting the driver to a problem. Additionally, electrical demands that exceed the system's capabilities may fail, leading to malfunctions in electronics, such as headlights flickering or audio systems cutting out. The vehicle's battery may show signs of failure, such as difficulty starting or frequent discharges. In some cases, severe voltage fluctuations could cause the engine to stall unexpectedly, creating potential hazards while driving. Lastly, erratic electrical behavior, such as random resets of the audio or navigation systems, can indicate deeper issues with the vehicle's electrical architecture. The first step in troubleshooting DTC P1549 involves turning the ignition switch to the on position. This enables the vehicle's electronic systems without starting the engine, allowing full access to data and diagnostic tools. Prior to any diagnostics, it is crucial to record all freeze data and onboard snapshots, which provide important context about the conditions that led to the fault code being set. Reviewing any general troubleshooting information available will also assist in understanding the overall system behavior. Following these preliminary checks, using the Honda Diagnostics System, HDS, the next action is to clear the DTC from the vehicle's memory. This reset is vital to allow a fresh assessment of the system without interference from previous errors. Once the DTC is cleared, the next step requires starting the engine. It is important to check specific vehicle conditions while conducting this step to ensure accurate diagnostic results. Ensure that the air conditioning, AC, is turned off, as it can draw significant electrical load and potentially mask underlying issues. Additionally, both the headlights and rear window defogger should be off, as they also contribute to the electrical demands on the charging system. Performing checks under these specific conditions helps isolate the problem, ensuring that any detected voltage readings are not influenced by additional electrical loads. This systematic approach ensures the diagnostics remain focused solely on the vehicle's charging system performance. The third step in diagnosing DTC P1549 involves maintaining engine speed at 2,000 RPM for a full minute. This can be done with either an automatic transmission set to park, P, or neutral, N, or with a manual transmission held in neutral. Maintaining a consistent RPM allows for testing the charging system under a controlled load while minimizing other influencing factors. After holding the RPM, a conditional check must be made to assess the system for any pending or confirmed DTCs. Using the HDS, this step is critical, as it verifies whether DTC P1549 reappears during this specified condition, indicating a persistent issue that needs attention versus an intermittent failure that may not necessarily represent a scalable problem. During the fourth step, after checking for pending or confirmed DTCs, it is crucial to determine if DTC P1549 has been indicated again. If it appears again, the immediate action is to replace the alternator due to its failure to regulate voltage correctly. This replacement addresses the core issue of the high voltage within the charging system. Conversely, if DTC P1549 does not appear, it may suggest an intermittent failure, implying that the system appears to be operating normally at that moment. However, it is essential to conduct further checks for poor connections or loose terminals at both the alternator and the underhood fuse/relay box, as these could cause sporadic electrical performance issues. Addressing these connections can not only remedy the immediate concern, but also prolong the life and reliability of the electrical system. The fifth step focuses on resetting the engine control module, ECM, or powertrain control module, PCM, after the repair or replacement of components. Begin by turning the ignition switch to the on/I position before proceeding. Using the HDS, reset the ECM/PCM to establish a fresh baseline for engine operation parameters. Following the reset, it is necessary to perform the ECM/PCM idle learn procedure, which allows the engine management system to adapt to the new settings or components. After completing this procedure, start the engine to allow the system to return to normal operating mode. This reset and recalibration ensure that any previous adaptations or learned behaviors are cleared, creating an updated and accurate operating environment for the vehicle's technology. Once the ECM/PCM has been reset and the idle learn procedure has been performed, the sixth step requires repeating the earlier conditions. Ensure that the AC, headlights, and rear window defogger remain off to isolate the charging system for the evaluation. It is again necessary to hold the engine speed at 2,000 RPM for 1 full minute, similar to the earlier check. This repeat assessment is crucial for verifying that the system is functioning correctly without interference from additional electrical loads. Accurate readings under these conditions will confirm if the previous repairs or adjustments corrected the high voltage issue within the charging system. The final step in this troubleshooting process involves checking for any pending or confirmed DTCs, again with the HDS. If DTC P1549 is indicated, it prompts immediate action for further diagnosis. This step emphasizes checking connections again, particularly those at the alternator and underhood fuse/relay box, as they are often overlooked, yet are critical in ensuring a reliable electrical system. If these connections are verified as secure and the issue persists, it may indicate an underlying systemic problem that requires comprehensive examination. However, if DTC P1549 does not reappear, the troubleshooting process is complete, and systemic health has been restored, unless other pending or confirmed DTCs are identified, directing the technician to subsequent diagnostic protocols. Final verification of repairs is essential to ensure the successful resolution of DTC P1549. Start by confirming the repair outcome through visual inspections and tests to verify the integrity of newly installed or repaired components. Review the diagnostic trouble code history to establish whether the previous DTC indicating high voltage is still present. Performing a thorough road test of the vehicle under various conditions is also a crucial step to confirm that the charging system operates correctly and efficiently. Assessing system performance will involve monitoring voltage levels and ensuring no warning lights remain illuminated on the dashboard. This final verification procedure ensures that both the customer's safety and vehicle performance standards are met. To prevent recurring issues related to DTC P1549, regular maintenance of the vehicle's charging system is imperative. This includes scheduling routine system checks to monitor the various components for signs of wear or failure. Regular inspections of electrical connections, particularly at the alternator and fuse box, can help identify potential problems before they escalate. Maintaining the alternator's health through periodic testing can also assist in guaranteeing that it operates within the required parameters. Proactively replacing any faulty components, including the battery when performance degrades, can crucially extend the lifespan of the vehicle's electrical system. By establishing a preventive maintenance schedule, you can significantly decrease the likelihood of high voltage errors in the future. In conclusion, understanding DTC P1549 charging system high voltage enables effective diagnostic processes for the Honda Civic models from 2006 to 2011. By adhering to systematic troubleshooting steps that include checking conditions, testing connections, and verifying repairs, technicians can successfully pinpoint and resolve the issue. It is equally vital to incorporate regular maintenance to uphold the health of the electrical system, significantly reducing the risk of similar DTCs appearing in the future. Ultimately, ensuring the performance of the vehicle's electrical architecture not only enhances safety, but also contributes to the vehicle's dependability and customer satisfaction. Please like and subscribe to the channel. See you next time.